Hi, everyone. Good evening. My name is Justin from the RFS Communications Committee. And on behalf of the Resident Fellows and Student section, I'd like to welcome everyone to tonight's very informative session on artificial intelligence in the field of IR, brought to you by the Research and Innovations Committee, with Dania Day, the chair, here to help present for us. So before we start, I just want to let everyone know that we're kind of doing something special to make it more interactive. If during the session, since we're trying to make this more of a discussion session, if you guys have any questions, you can either type into the questions box. There's a drop-down menu where you can type something in, or there's also a raise your hand function. You can do either way, and then we can unmute you, and then you can bring your question up, and we'll make it into a discussion. The session, like always, is recorded and will be made available on YouTube at a later time. And that's about it. So without any further ado, I'll give the mic over to Dania here.
Thanks, Justin. My name is Dania Day, as Justin mentioned, and I'm the chair of the Research and Innovation Committee this year. The committee will be sponsoring a number of webinars over the next few months, and our first webinar today is about artificial intelligence in IR. And today we have an excellent lineup of panelists. We have Dr. Andrew Taylor from UCSF, Dr. Matt Lundgren from Stanford, and Chris Treml representing the Data Science Institute for the American College of Radiology. The panel today will be moderated by Kevin Seals, who is currently a fellow in interventional radiology at UCSF. With this, I'll turn it over to Kevin to start the discussion. Kevin.
Yeah, hey everybody, this is Kevin. Dania, thanks so much for organizing everything. I'm really excited about all the panelists we have here tonight. So we mentioned Ed Lee was going to join. Unfortunately, he got stuck saving someone's life or something like that in some emergent case. So he's going to join us if he can, depending on how quickly he can do that. But anyway, you know, the plan today is to really focus on machine learning specifically in the context of interventional radiology. You know, so we're always talking about machine learning in radiology. You know, we've read 1,000 articles about that and seen 1,000 talks about that, but you know, much less commonly do we focus on specifically applications of machine learning to IR. So we've got some of the kind of leading experts in that space here with us today, which I'm really excited about. We do really want to make this more of a conversation than just us talking. You know, so you can type a question at any time and we'll try to kind of integrate that into you know, chatting with the speakers. And then there's also that kind of raise your hand functionality and we can unmute you. And, you know, ideally we'd have an actual verbal conversation rather than just typing out questions. But you're certainly encouraged at any time to you know, give us any question you might have. But anyway, to get started, we'll have our speakers sort of introduce themselves, give a little of their background and sort of the stuff they've done in the machine learning space, kind of their background in IR and so on. So we'll start with Dr. Andrew Taylor. He's based at UCSF. He's one of my attendings. I'm in fellowship now. And Dr. Taylor, if you'd kind of just discuss your background, your interest in machine learning and sort of the stuff you're working on.
Sure. Thanks for inviting me, guys. I really appreciate it. I am an interventional radiologist at UCSF, Kevin mentioned. And before I was a radiologist, had an interest in computer graphics and working with images and so forth, and sort of was looking for ways to continue to do that in my career in radiology. In interventional radiology, as I'm sure many folks out there do, I do a wide range of procedures, focusing quite a bit on interventional oncology, both angiographic procedures as well as direct percutaneous ablations and so forth. My interest in machine learning, I think, really was an attempt to bring together some of my interest in image processing, image analysis, and kind of messing around with technology and bring that into the radiology realm. I will say that actually most of my work so far has been not in the interventional space, potentially for some reasons that we'll end up talking about tonight. But as we were getting started with our projects and so forth, much more in the diagnostic realm, looking at things like computer vision for identifying acute findings on x-rays and triaging them, et cetera, prioritizing work lists, and doing some early work in NLP and sort of report mining and so forth.
Cool, thank you very much. And so next we have Dr. Matt Lundgren coming from Stanford. Really impressive guy. He's done so many cool projects that I'm sure we've all read about online. Recently got an R01 grant and has done all sorts of cool stuff. So Dr. Lundgren, if you'd kind of discuss your background, sort of the stuff you've done with machine learning.
Yeah, thanks for the intro, and hopefully we'll live up to that. So yeah, I'm here at Stanford. In terms of my clinical job, I'm an interventional radiologist in the pediatric section. So I'm actually a pediatric interventional radiologist. So most of my work focuses on pediatric interventions, a lot of vascular malformations, and the occasional oncology work. And in terms of the machine vision and research, you know, again, you're not going to be seeing a lot in terms of the IR subject matter, I think, and that's kind of something we can talk about certainly. But a lot of my work has been focused on, again, diagnostic, different modalities like chest X-rays and MRIs and others. You know, and the other thing that we tend to work on, which isn't quite as exciting, but is really important, is again NLP, which is natural language processing for you know, pulling out structured labels from free text reports, and that's a critically important task for a lot of the work that we do. I think that my focus is starting to shift away from just developing models with teams and more towards implementing models and seeing how it works in the real world. I think that that's been an extremely exciting thing to see happen, both giving AI models to radiologists to see if it makes them better. But one of my keen interests is giving AI models to clinicians and seeing if they can perform at the same level as an expert radiologist. And that's something that I'm really interested in doing and that we're doing here at Stanford. I'm also the associate director of the AMI Center, which is the Artificial Intelligence in Medicine and Imaging Center. And it's just sort of a kind of an umbrella group within Stanford that helps us coordinate interactions between other departments like pathology and cardiology and ophthalmology and dermatology, with various groups in the computer science and electrical engineering departments, so we can kind of have a coordinated effort for a lot of the projects that we do and learn from each other and have a good time along the way.
Very, very cool. Well, thank you guys. And so the first thing I wanted to discuss was kind of use cases for machine learning and interventional radiology. You know, we've kind of mentioned that a lot of the stuff that's happened so far has been in the realm of diagnostic radiology, but you're both two of the top sort of machine learning radiology experts that are also interventional radiologists. So I think you're kind of the best people to talk to with regards to, you know, what's to come and what we're eventually going to be able to do with machine learning and IR. I think a lot of people don't really understand the applications all that well per se. You know, people might think, you know, if we're going to use machine learning and IR, do we need like robots that are there like performing procedures, or, you know, is there some middle ground, some smaller step in that direction to start implementing some machine learning and IR? So kind of the first question I have for you guys is, what do you think are some of the most interesting and promising use cases for AI in interventional radiology?
I'm happy to start off. This is Matt. Yeah, so you know, we talk about this a lot because, you know, I'd love to have a little bit more of my clinical life match up with a lot of my research life. I think you know, that's kind of nice just for sanity. But I will say that, you know, one of the nice things, and I think one of the reasons that I think others might echo about being an interventional radiologist is when you get to work in this area, you kind of don't have as much personal stake in the outcome. If whether it's related to, you know, is my job safe kind of stuff, or is it related to, you know, well, of course it's not going to do as well as me. We kind of, as an IR, we kind of have enough domain knowledge to implement and work on some of these projects without having to feel like we're directly, you know, impacting our clinical world. But I will say that in terms of, you know, IR specific projects, there are things that I think folks are doing or have done. I think there was a mediocre kind of effort at doing like a pick tip position type paper. I remember seeing that somewhere. I know there are folks who have worked on IVC filter detection, identification, things like that. But for me, it's tough, and I think some of the principles of machine learning apply here. Generally the better use cases are those that you have a lot of examples of a certain type or a certain class. And as many of you know who spend any time in IR, 90% of our job is figuring out things as we go, because there's changes in anatomy. The plan often changes as we sort of learn more information during the procedure, and sort of having an opportunity to sort of find enough cases that are alike enough for a specific important clinical problem is tough. That being said, I think, where we can have a tremendous amount of value, but it won't be quite as sexy in terms of doing the doctor's job, quote unquote, but being able to predict who will respond to a taste, for example, being able to leverage deep learning to process massive amounts of historical retrospective data, both structured and unstructured, in order to better triage or better suggest treatment options for patients, I think would be one possible and probably a really great opportunity for deep learning. I think in particular for IR patients who are being triaged at a tumor board, for example, or you're trying to decide taste versus ablation or other kinds of decisions that somewhat are practice dependent, not always evidence based. And certainly we have enough volume collectively that potentially that could be a place to look at. But again, not a lot of imaging type projects that immediately come to the forefront as low hanging fruit compared to with a lot of the diagnostic tasks.
Got it.
Yeah, I would agree with everything that was just said. I think that there's this a sense still to sort of associate AI with computer vision. And as we know, computer vision is something where the more examples you have of a well-structured image or exam, I won't say easier, but probably the better you're going to do initially. And I would say the average interventional radiology exam is just so much less structured than the average diagnostic exam, if it's a chest x-ray or a CT, et cetera, in terms of how the information is presented, what the orientation of the patient is, the field of view, those kinds of things. And so, yeah, coming up with meaningful or useful examples where you have large numbers of cases as training data is challenging. And I agree. I actually think that the areas where I see really interesting things in the field of interventional radiology is going to be things like, as you say, sort of potentially looking at molecular markers or pathology and saying, well, this tumor potentially has the phenotype of one that will respond well to a particular kind of intervention, or maybe something like even prognosticating these patients do well or don't do well with things like Plerex catheter placement, or how will people do after gastrostomy placement. So some of those things are not as sexy, but I think they actually are going to require data from a number of different sources beyond just the imaging itself. And I think that that's actually, in terms of adjunctive things that can help the interventional radiologist. I mean, Kevin, some of the things that you're working on with the voice commands, et cetera, I think that is something that really could have a very strong impact in the IR suite, much more so than sitting at a workstation if you were a diagnostic radiologist potentially. But those are areas where I think you're going to see really interesting use cases, again, drawing on data from a variety of sources and not just the picture itself.
Absolutely, very cool. And then, we actually have sort of a bonus panelist who's, another really impressive guy and doing some work specifically related to good use cases in IR and other branches of radiology. Chris Treml, who's the director of the Data Science Institute at the ACR. I know there's a lot of interest about what's going on at the DSI and how that kind of relates to IR and machine learning. So Chris, if you could sort of introduce yourself and give us a little kind of intro to the DSI, that'd be wonderful.
Hi, yeah, thanks. So where the DSI is our kind of goal and what we were owning inside of the ACR overall is this kind of idea that I think folks right now are already talking about, where we see a lot of this potential behind AI, and we see a lot of folks trying to do it, but there's just this gap that's happening of actually getting it to clinical use. Sometimes it's just particular entities who are trying to push it out there are a little too gung-ho, but oftentimes too, there's just a lot of these overall, I would call like infrastructure gaps, whether it's the gap between the folks who are on the technical side creating these types of algorithms versus the clinical side who understands the detailed nuances of how it has to play out, to just all kinds of other different IT and just clinical workflow gaps that are going on. And so what we're looking at is what can a body like the ACR do to help push along in these different areas to help get this technology to a point where it's in your clinical workflow and you're able to use it to deliver better patient care for your patients. So one of our major activities around that is where we have different groups that we're calling panels around different subspecialty areas of radiology that are focused on developing these use cases. We're going to be having these being publicly posted on our website in about, I think, 3 weeks is when it's going live. We're calling it the Touch AI directory, and what it is essentially, it's a set of different use cases or clinical use cases that outline what the impact is to the patient care, or what the impact is to the practice, and why it's important and how it's beneficial. And then also it outlines a lot of other details too in terms of how it should be used. What are some of the technical specifications behind it? That way a vendor could take a look at and understand how they could go about trying to solve this. So does a particular use case, does it need only the DICOM images to actually work, or do you need the DICOM images plus you need the indication of use, plus you need to have the patient's problem list or pathology in other areas as well. And then also kind of the details too about what we're asking them to solve. So instead of just saying, is the catheter tip placement correct? Is it a yes, no? But what's actually the most clinically relevant data around that? Is it actual, maybe what we want to have is a location? And if we're going to say location, how do we define location in a way that's actually useful to be consumed by you for your patient care? And one of our panels is for interventional radiology. And what I think is interesting with interventional radiology is also what the other panels have called out, is that I think there's a little bit of a momentum problem versus diagnostic radiology, because in diagnostic radiology, folks have already kind of called out and tested algorithms and scenarios already that show how it could work. And now it's more of a matter of how do you make it robust enough and actually deliver it. And then you can kind of look to those previous ones and kind of keep building up and building up. And one of the things that we're working on with the panel right now is we have a series of different kind of ideas and of use cases that our folks are drafting up and thinking about and authoring. But I feel like what we're hitting here is that interventional radiology is just, it's different enough that you can't just look at what diagnostic did and automatically clicks what you could be doing in your area. So there's this initial gap of, until we get a couple of solid use cases that folks agree to are beneficial and can be accomplished by AI right now. And once we get that, I think we're actually going to get the ball rolling a lot more, start finding more and more and more areas that this will be helpful.
Awesome. Well, yeah, the DSI is doing some really cool stuff, and I definitely recommend everyone to look into that and do what you can to get involved. Going back to the topic of use cases now, so one thing that I find really intriguing is how we can use machine learning to kind of detect features in images that the human eye can't really appreciate. So in some sense, it's like giving radiologists superpowers. So for example, we can see things in like the texture of a tumor, like subtle little things that might be predictive of like a certain genotype or a certain response to to TACE or some other IR procedure. So I was hoping Dania could speak on that a little bit. I know that's sort of a component of the work that you're doing, Dania, and it'd be cool to kind of touch on the interesting things we can do in that space, and whether, those sort of machine learning approaches can give IR physicians sort of superpowers in the future.
Sure, I'm happy to briefly comment on that. I mean, for a very long time, a number of people have been doing a radiomic analysis of different tumors or other structures that we see on radiologic images, and trying to correlate those features to either genetic information or patient outcomes, among other things. So one of the ideas that I'm currently working on is it possible to extract subvisual features that are currently not necessarily visible to radiologists' eyes and try to correlate those with patient outcomes or response to therapy, in our case, in IR. So, for example, in the case of ablation or other IO procedures that we can we do some radiomic analysis on the pre-procedural images and be able to really subclassify patients on those that are likely to benefit from the procedure that we're going to provide versus those who are not, and really try to drive more towards a personalized medicine approach when it comes to the way we approach IR. I mean, I think this is an area that remains underexplored, but might be a potential area for us in IR to consider as this field continues to grow in terms of computer vision applications and potentially eventually incorporating machine learning for prognosis prediction or response to therapy prediction, among other things that we can do.
Insanely cool. Very, very cool. So as kind of a follow-up to the use case question, something that I thought would be kind of interesting to have everyone ponder is like, and it's going to be a little speculative, but I think it's fascinating. As we talk about these use cases, we're really thinking about what's coming out of the pipeline now. What are we likely to have in, a year, 2 years, 3 years? I was wondering if you guys could sort of give your thoughts on what you think is going to happen with machine learning and IR a little more long term. So on the horizon of 10 years from now, 50 years from now, 100 years from now, what sort of crazy things are we likely to be able to do as things get more sophisticated? And similarly, long term, will robots be able to potentially perform interventional radiology, or where are we going to get exactly? What do you guys think about that?
Well, I'll tell you right off the bat that I am terrible at predicting the future. I've learned this about myself over time. But I think that you raise an excellent point, which is that right now there's a lot of gee whiz about what can be done in the moment and then sort of prognostication as to what can be done going forward. But I would say, in the longer term, I don't see why there couldn't be significant portions of procedures that could be at least partially automated. I mean, think about placing, say, a temporary central venous catheter. There's a lot of work and there's a lot of devices that would have to be built to do this, but you have a relatively standardized anatomy, and you have the ability to potentially use ultrasound and identify the difference between a vein and an artery, hopefully, and potentially even to place a needle into that and so forth. You can see where I'm going with this, is that if you could in fact develop all of these things and break them down into sort of standardized repeatable tasks, then I think there is the potential that some of these things could at least be semi-automated. I have to say, when people ask about this kind of thing, when they ask me about, where's this going to go in the future, this crazy thing you're doing, I'm reminded of a piece of the book, The Wright Brothers, by David McCullough. If you haven't read it, I highly recommend it. It's a great book. But one of the things that he spends a fair amount of time talking about is that these two guys, in addition to being visionaries and amazing engineers and inventors and incredibly disciplined, one of the things that he argues really set them apart from some of the other people working in the field of making a flying machine, because there were many, is that they spent at least as much time, if not more time, learning the rules of this new thing that they were trying to do. They spent as much time like learning how to fly as they did making a flying machine. And so I think that that's I think that's something that we're going to have to really figure out as we go forward. You know, you don't want to find yourself in a situation of all of a sudden you've catapulted yourself into the air, and now it's like, great, how do I land without dying? You know, you have to. There's as much a new discipline of how to use or what can we do with the things that we're developing as there is just the development of the technology itself. So yeah, 100 years from now or shorter than that, is it possible that some of these things could absolutely be, you know, there could be aspects of a procedure that are semi-automated, at least, as I was saying. I would say yes, but I think it's very hard to know what some of the earliest incremental changes and what are some of the earliest things that we gain enough clinical experience with to know what works well and what's safe and appropriate.
Yeah, you know, this is Matt. My grandpa used to say the only thing you couldn't predict was the future. I think that's like generally the way to set off some of these futuristic comments. But I will say that, you know, in general, you have to think a little bit more broadly about the why. And you know, so when I think about, you know, the why of why would I want to give an AI model to an orthopedic surgeon so that they can read an MRI of the knee better, without having to wait for radiologists to read that I can see a use case. I can see a reason why that makes sense. And no matter how sophisticated or not the technology, you can the AI potentially provides time savings, a cost savings, an automation of a portion of the work that is required to do practice medicine. Now, when I think about IR, you know, certainly we can come up with, and we have seen, in fact, I believe out of Cincinnati Children's, they had an automatic vascular access robot that they had built. I believe it was a couple years ago. But, you know, why am I not thinking about that or spending more time in that area? Well, I'll tell you, know, so human labor is actually, you know, we're pretty easy to train. We're relatively inexpensive. We're relatively reliable. And to think that we're going to be in a place in let's just say 5 to 10 years, where we're going to have a robot that's going to be at the same cost, accuracy, speed, to do, you know, even half of what we do is probably a little bit far-fetched. I would say that there's portions of our collective jobs that we would like to see AI spend, or, you know, just generally more time in helping us with, and I think a lot of that, to me, has again more to do with you know, predicting patient outcomes, helping us make better decisions, maybe even cutting down you know, the different types of work that we're asked to do that maybe isn't necessary. Those kinds of things, I think, and going back to Kevin's sort of chatbot concept, I think there's a lot of opportunities around that to significantly reduce you know, the amount of brain power spent on things that don't require it. In 100 years, of course, that's, who knows, right? But I think that, you know, keeping it in perspective, you know, we aren't gonna take a jet plane to get from Palo Alto to San Francisco, even though that would be cool. We'll probably still be driving, and to some extent. So I think that there are places where it just doesn't make a lot of sense to spend a significant amount of effort, and certainly. I'd be happy to be proven wrong by some robotics genius out there, but in general, I think we're still in this place where we're thinking more about replacing parts of the medical labor that has a very big upside in terms of savings and cost.
Got it.
Yeah, I would actually just add to that. I agree with that 100% over the sort of near to medium term. And this may be something that you're going to bring up later, Kevin, but also I think it's actually incredibly important that people are somewhat careful in terms of the kinds of things, the kinds of promises that are made and the kinds of things that come into the clinical space first, because, you know, everybody wants to have the amazing, just incredible thing, but that's also known as swinging for the fences. And if you swing for the fences, you're just as likely to strike out. And I think that there is at least I have a concern that what this field needs to avoid skepticism or potentially massive disappointment / backlash is some solid, incremental, meaningful advances that are useful to radiologists to clinical physicians, et cetera. And yes, hopefully the home runs will come down the road. But if everybody starts out trying to hit that home run and there are some spectacular failures, that could actually set the field back, in my opinion, in terms of adoption into the clinical space.
Mm-hmm.
I'd echo that too. I just, to tail into that, I do think that there is a big price to be paid for the excitement and the hype. And while there's certainly an upside in terms of attention and opportunities, I think that the downside is that sort of an overeager implementation effort that without fully vetting it or understanding the ability to generalize a given project or model. You're right. We'll quickly turn the other direction, and sort of. I think that maybe that's something that I know the RSNA and I guess the ACR here. We're all trying to sort of figure out how can we be more responsible in advising some of these implementation efforts, but we won't be able to. It's the cat's out of the bag. So we can put a ton of rules and committees together collectively as radiologists. But I think that we all know that's not going to stop what we're seeing happening. A lot of it is not within our direct control or domain, and that's particularly true worldwide. And so I do have those same concerns about substandard work making its way into the clinical practice without the proper vetting.
Definitely. We definitely don't want to have a Theranos type situation in interventional radiology. And I just read that book, by the way, and it was awesome. But anyway, next question kind of shifts the focus a little bit to how exactly IR physicians can get more involved in machine learning. So, you guys have both done a lot, and you're kind of established names in the field, and you've done really cool things. And I talked to a lot of people that, there may be, a resident or a medical student or a fellow, a young attending, and they're, they think this machine learning stuff's really cool, but they just sort of don't know where to start. So if you guys could just sort of summarize your journey from, non-machine learning expert to where you are now, how you kind of made that progression, and just give any general advice you might have for someone that, currently has no background and kind of really wants to be where you are now.
Okay, I'll start. And I would say, first of all, I don't consider myself as much of an expert, but thank you. And I think the key thing is collaboration. There are so many aspects to putting together a good project that I would say it's impossible or extremely unlikely that one person is going to have all of the knowledge, skills, experience, resources, et cetera, to do a project like this. But on the flip side of that, I would say that almost anybody who is interested and is willing, if you find the right people, there will be a niche that you will fit into. Maybe you're a programmer, maybe not. Maybe you know something about statistics, maybe not. But if you are a radiologist, say, or a radiologist in training, you certainly have some domain knowledge that not everybody's going to have. And my experience has been that the domain knowledge that we have as physicians, yes, we can interpret an image, but that's not where 99% of the hard work and the hard decisions get made in terms of the quote unquote clinical expertise. It's actually finding out or knowing from experience, well, what's going to be a clinically useful thing? So maybe we have some detector that detects, I don't know, insert your favorite finding here, but is that meaningful, and how does it affect care, and how does it change care? And I think that interventional radiologists in particular have a particularly advantageous position here in that the IR folks, they know all the radiologists in their department, but they also know an awful lot of the clinical people and the hospital teams that are rounding every day. And they are one of the major points of contact between other clinical services and the Department of Radiology. And so do not underestimate, even if you don't have technical skill, do not underestimate what you do have in terms of knowing who to talk to, knowing what's relevant, and potentially what would be useful both to you or to another clinical service.
Yeah, I definitely second that, and that's a terrific comment. I think the journey will be different for everyone, but I think that the emphasis on domain expertise is key. I think I've seen many projects that were led primarily by computer scientists or electrical engineers without a lot of medical guidance. And they weren't useful projects. They weren't clinically important. And that's something that would have been clear from the beginning, and possibly even a medical student or someone from that level could have contributed an enormous amount to some of these kinds of projects that are going on, and vice versa. I've certainly seen a lot of folks in the medical groups who have put in an inordinate amount of time, and maybe it's a hobby or maybe it's something they're personally interested in, but spending time learning how to deal with deep learning models, to manipulate the data. And I think that's great too. But, especially to have the conversations with collaborations, but collaboration is key. And I've yet to meet someone who can, serve as a domain expert from both sides and still be an effective, still come up with an effective project. And to also point out the fact that as radiologists, as radiology residents, you have a tremendous amount of knowledge and value that I recognize seems very ordinary because you're surrounded by physicians and fellow radiologists, but is extremely extraordinary outside of your domain, outside of your area, and is of extremely high value. So the things that the things you've learned, your understanding of use cases is gold. It's very, very valuable. And I think the best collaborations occur when both parties have sort of aligned interests. They're willing to share and learn from each other, and sort of work towards a common goal. The last piece I'll say, which is an ingredient that I think is true for any project or any successful career, is the hard work part. These projects are great and they look quote unquote easy, but it's a tremendous amount of work on both sides of the table. And the work for the clinician is not to be, sort of passed over. I mean, the amount of labeling, curating the data sets, getting the data, doing all the approvals, dealing with the clinical use cases, and then of course the implementation components, if that's part of your mission or goal. That is a tremendous amount of work, and really best done by you. And so I feel like this is not something to be intimidated by. If you're coming from the radiology side, if you're a resident looking to get into it, it actually doesn't take a whole lot, frankly, if you can sort of work with your groups to get IRB approvals and data sets that you can work with and partners. You'd be surprised how easy it is to start getting something off the ground if you're willing to put in the work and you're able to partner effectively. So anyway, that's kind of a long-winded way of saying the same thing, but again, it's just the idea of collaboration and partnership, I think, is really where these kinds of things start to take off.
Yeah, really good points. And I think one particularly important nuance is that, there are a lot of people who are in radiology and want to do machine learning stuff, but they say to themselves, I don't have any computer science background. I don't know anything about engineering. How can I help out? What value could I possibly offer here? And as you guys really point out, there's plenty that anyone involved in radiology can do to be really helpful and effective if they're willing to work hard. So that's an important thing for everyone to remember. So next question, kind of relates to the disconnect between these research projects we're doing and, real products and clinical AI tools that are actually being used. We spend a lot more time thinking about this stuff and discussing it at conferences than we spend using it clinically. I've hardly seen anything in the machine learning realm used clinically at all, practically speaking, although I know there are a whole bunch of companies. Are there any particular companies that exist right now that you guys find particularly exciting? And in general, with these dozens of companies that exist, do you have any suggestions regarding, how to evaluate them, how to identify legitimate value versus just noise in this super crowded space?
I will say that it's probably mostly noise anyway. I mean, that's just how it is, right? With marketing and PR, I think that. But I will say that what I've heard about RSNA this year, and I would certainly encourage you recognize it's not a very IR heavy meeting, but if you have any remote interest in AI, this is the year to go. Certainly there will be an inordinate amount of companies, the vast majority of which you've never heard of. They're sort of hawking their wares, and I think that some of the things to think about, as you're suggesting, are some of the things that we think about when we evaluate, science. I think that someone telling you that they're accurate, we all recognize that that's a poor judge of performance. And an easy example is a mammo screening board. If you say that they're all negative, you're going to be pretty accurate, right? But that's not very helpful. And so think about the prevalence of the test set. You generally have to look at the claims and sort of really take a step back and think about how that was obtained. And then the final piece is, even if it does tend to check out for whatever particular claim that they're making, the biggest piece is the generalizable piece, and that's sort of the dirty secret of a lot of these models, is that they're brittle. And while they may work really awesome at Stanford, I may take it up to UCSF and I'm going to see a performance dip, and we know that's going to happen. How we get around that is still an active area of exploration, and it's really fun to be a part of that part of it. But if I'm running a company, that's something that worries me, right? Rather than being excited by that, because I know that implementing my model at your hospital, it may not perform to the way that I promised or had on my data. But taking those kinds of things, obviously keeping a skeptical mind, I think is important. And then ultimately, and something that we were sort of looking towards is, can you find reliable users or use cases where you can say, hey, this person has used this in clinic and found it to be helpful for these various metrics. That's another thing where we're not really even clear, I think, as a group, and if I put myself in the overall group, of what metrics we're actually looking to achieve with some of these models. Are you looking at cost savings? Are you looking at making radiologists faster? Are you making us more capable of measuring things? I mean, what are we actually trying to achieve? And is that something that's worth doing?
Yeah, I would second essentially all of what was said there. I feel like having gone to the last couple of RSNAs, we've already started to see a little bit of an evolution between a couple of years ago and say last year, in terms of first of all, what companies came back from year to year in terms of the ones that had survived even that long, but also in terms of the kinds of conversations that you could have with some of them. I'm exaggerating slightly, but the first year there were conversations that were sort of like, so what can you guys do? Oh, we can look at any data, any sort of imaging study, and offer a complete report. Oh, okay. So what are you looking for? Well, we're looking for cancer. What kind of cancer? Well, any kind of cancer. They were very, very general conversations, and that actually wasn't too far different from some of the conversations that I had with people the first year. And I found that in talking to companies in the last year or so, people have started, the ones that are still there are the ones that actually have an idea about a specific, potentially achievable use case. And so having a conversation with those people, I found it helpful to ask them, just like what Matt was talking about, like, what is your use case? What are the performance metrics that you're using to evaluate? If you get an answer about accuracy, overall accuracy, that may be not particularly useful, but maybe if you ask about, well, so what is your sensitivity? What is your specificity? And then dig down even further on that. So, what is the prevalence of the finding that you are trying to find? Is it a very low prevalence finding? Is it a very high prevalence finding? And therefore, what are the kinds of thresholds that you and your company think are where your device or your product achieves some sort of meaningful utility? If you have a great sensitivity, but you do so at the cost of 1 million false positives, that may not be very useful. Even if your sensitivity is 100%. So, you have to sort of talk to these people and see if they can offer you specifics about what they're trying to accomplish and what they have set as their goals or their thresholds for where they think they have something that actually kind of works. And then as to the generalizability, that is absolutely a major problem, and I think will continue to be a big problem. And my hope is that we'll see more and more efforts to have publicly available sort of large data sets. And those are, I applaud the people who have put them out there. I feel like they take heat for what doesn't work well with their data sets or their annotations, but the fact that they're out there and that they're working on them is very, very impressive, and I think it'll be really meaningful going forward.
Absolutely. And kind of a follow-up question about industry. Do you guys have any sort of general advice in terms of interfacing with industry? Like, should people in academics generally avoid doing that, or can it be useful, and can you have a fruitful collaboration? And a related point, should we collaborate with a big company like Google and do some sort of data sharing thing where we kind of harness some of their engineering power, or is it better to partner with a small startup, or avoid that sort of thing altogether? Do you guys just have any sort of general principles or thoughts with regards to industry interaction in academic medicine?
Yeah, I mean, I think that maybe you guys have seen the recent article, so this is a pretty timely question, and may direct some of your ability to even do it if you were interested in terms of collaborating it. So, Sloan Kettering had a fairly widely publicized article about them I guess it's been about a week or so in the New York Times regarding their sharing of data and exclusivity with a startup that was spun out. And of course, the stakeholders were staff, physicians at the pathologists. And, those kinds of things don't really sit well with the public. And I think that, increasingly we're in a very difficult environment, where privacy is a top concern. And I think that we're kind of fighting against the forces of these large companies who need the data in order to do this kind of work and advance their agenda. And so they're perfectly willing to partner, and certainly willing to partner with other academic centers around the country and even the world in order to get enough data to do the work that they plan to do. And I would encourage anyone thinking about this, whether it's a startup who's raised some money or a large company, to think very critically, of course, and even if it is approved and everyone's signing and everyone's okay with it, to consider both the sort of the perception of what's going on and whether or not this ultimately is a data for cash kind of a transaction, or is this actually a co-engineering or a investigatory research project where you're actually going to have a research or a scientific product at the end of it. And then that's something that we talk about a lot, and one of the reasons why we try to release all of our data publicly as soon as we are approved to do so. We tend to do that because, again, it really does take the burden off of any sort of exclusivity or concerns about someone profiting from patient data that ultimately could benefit the rest of the folks in the community and the world that are working on this. So I don't want to be the Debbie Downer. I think that there's a lot of great opportunities to work with large and small companies both, and even if you have your own idea, maybe you've developed a model and you're thinking about a startup. But I do feel like the public perception of that and those outside of the bubble we live in here too wouldn't necessarily feel as comfortable with that kind of a relationship if they knew it was their data that you were making a profit from.
Mm-hmm.
Yeah, I agree 100%. My collaborator and I, we like to talk about that, like, so is this more of a collaboration or is this more of a we're just a data vending machine kind of proposal, and try to stay far away from anything that sounds like that. I think it's very, very challenging in the sense that academic centers and clinical centers where they have the data and they have the people with the domain expertise are very logical places for proof of concept and so forth to get off the ground. But we'll see how all of this shakes out as regulatory sort of how the regulatory process is developed and refined for these. But it may be very difficult or impossible for some of these things to go, large, to scale up and to become more commercialized or more distributed without some sort of industry partner, because that's what business is, or at least that's what some businesses are very good at, and that's what they're sort of scaled up for. But on a personal or a small scale note, to people who are doing projects at maybe as a resident or a fellow, et cetera, you may get approached by a contact in industry, et cetera. And what I would say is, first and foremost, identify who the people in your institution are, in terms of making sure that if anything is going to go forward, that you are in line with the privacy requirements and the sort of general approach that your institution has to working with data, sharing data, working with outside of the university or the institution, because the last thing you want is for some well-meaning project that you have or idea that you have to somehow create a data disaster or a public relations disaster. So I'm not saying don't do it, but I guess I'm sort of falling into the Debbie Downer category as well. I'm not saying don't talk with people, but definitely talk to everyone you can think of in your institution before you get too far down the road with those things.
That was my dog barking, sorry. Sorry, I got distracted there. Did you finish your thought?
I did. Right as your dog barked, I said my last sentence.
And as my wife walked in and started baby talking him. But anyway, yeah, so I'm also kind of in a Debbie Downer headspace with regards to this sort of thing. I had an experience before where I tried to collaborate with a big company, and in terms of getting that big company and their lawyers to interface with, a big academic medical center and that other set of lawyers, and really carefully handling the privacy issues and so on, it became just untenable and awful, and I personally don't think it's the best idea either. But let's see. I'll ask one more question, and then we'll open it up to audience questions and try to finish up pretty soon here. So my last question would be, there's so many skill sets that you need to develop one of these algorithms and get it out there and working. You need medical expertise, engineering expertise. You need to understand, regulatory issues. You need some understanding of, the economics of rolling something out and so on. What do you guys think in terms of, how much engineering should a radiologist know to release something, or should it be purely is it best to be collaborative and have, an engineer and a radiologist, or what sort of mix is optimal for a team, and what should people do to be kind of optimally prepared to create this stuff in terms of their own skill set and their partnerships and so on?
Yeah, I tried to touch on it a little bit earlier too, but this is a great question that comes up a lot. And I think that if you're really ambitious and maybe you don't or aren't successful in finding great partners or collaborative partners in your institutions or in your circle, there are plenty of online resources, many of which are free, that can get you to a place where you'd probably be conversational enough to sort of get some small projects done. You'll never get to a place unless you're willing to devote some significant time and maybe even have some mentorship or dedicated classes or coursework to the point where you're going to in my view get to a place where you're going to be publishing at the same level as some of the larger collaborative groups. And I think that makes sense to those of us who have respect for our own domain knowledge. It's very interesting. I had a group one time early on in one of our collaborations, and one of the students was held back for a second, asked me, wanted to pull me aside and ask me a question. He's like, is there just some kind of book I can read to learn, medicine and stuff, and then I can just do that part of it? And I sort of thought, that's kind of an interesting question, but you would have to spend a little more time than probably just looking at a book. And I think the same goes from their perspective too. I think when we say things like, "Can I just take some classes and do that kind of stuff?" I think that does take away from the sort of the level of expertise necessary to really be at the cutting edge of this field. And so I think from that perspective, it's pretty clear that collaborations are important. But one thing I did want to point out that does give me pause when I sort of say that as firmly as I have is, there are actually companies, believe it or not. So in very similar to the old gold rush, when people rather than trying to get to the mines first, they actually just sold the pickaxes and equipment to do the mining. There are companies now talking about or have put together basically a virtual grad student or a virtual computer scientist. In other words, if you came at it with data and labels, you could get to a place where you literally upload your data, drop down menus for different types of architectures, and you can do some fine tuning at the end. But it's all very intuitive and sort of a GUI interface. Those kinds of things are happening. So maybe at some point, a lot of the expertise to do some of the simple initial pushes on data sets to see feasibility and things like that will be possible without having to have a large collaboration. But I think in general, it's probably the ideal way to go, particularly if you're looking at an academic route.
Yeah, I think collaboration is obviously is really key. To touch on some things that Matt was talking about before in terms of what you can learn and what you can do and where you might put your hard work. Yes, if you want to learn to program, I think it's helpful. Like, I am not a great programmer. But I collaborate with people who can program so well. But it's helpful to read about it a little bit, to learn some of it, to be conversant in it. But I think that even before you reach that point, there is so much work to be done. And in fact, so much of this work is what can ultimately sort of determine a lot of the quality of your final product, which is in the data set curation, collection. Even I found myself going back, let me read more about machine learning and programming in Python or with TensorFlow, and pretty soon I find myself saying, I don't really remember that well enough, so it's back to linear algebra and watching courses on matrix operations and so forth, or something else, going back to statistics and learning about data sets and stratifying data sets, balanced versus unbalanced, so many things. And none of this is incredibly hard to go back and learn something about. And the more that you can sort of make yourself familiar with these kinds of things, I think the more you bring to the table. But you don't have to be the computer science expert. But if you understand your clinical problem and you understand your data set better than anybody else, like, you will absolutely be a vital member of the team.
Great points. And so, Dr. Lundgren, you'd mentioned some resources online that are good. Are there any particular resources either of you would recommend or find really valuable to getting at least somewhat up to speed in terms of machine learning stuff?
I sort of hesitate to sort of endorse any one in particular because there's always politics around some of that. But I mean, obviously, I've collaborated with Andrew Ng, who has quite a bit of content online. I mean, obviously, there's coursework available through Coursera and edX and Udacity. Those platforms have plenty of content from different academic centers, and I think there's another group, Fast.ai, I think that by Jeremy Howard's team. So there are certainly lots of opportunities out there, but I guess I'd be hesitant to sort of give a ringing endorsement of any particular one in a setting like this.
Got it. Thank you.
Well, you know what? I'm going to jump in and actually second that, in the sense that I have found that the Stanford offerings and so forth have been really helpful. So as someone who is outside of that organization, I appreciate the amount of stuff that's made available.
Yeah, me as well, for sure. But anyway, we should start sort of trying to wrap up here. Any questions from the audience or from Dania or anyone? Any additional questions for the speakers?
This is Diane. Thanks for an excellent discussion. I was wondering, you mentioned that in AI in radiology in general, one of the biggest issues is the translation of AI algorithms from the development phase into actual clinical practice. What do you think are the biggest obstacles to that translation to happen?
I think it depends a lot on the use case, number one, but I think that as a general topic or concept, you know, we are all in different bureaucracies, you know, IT bureaucracies in each of our hospital systems. That even though we use Epic, it's not the same Epic. It's not stored the same. It's not accessed the same. The packs are different. The way that we, you know, maybe our clinical workflow is different. So there's a lot of logistics. Even if you take a step back and you say, well, you know, if I could solve getting it into the clinic, well, then you have the sort of the stakeholder part. So, you know, are you trying to, who's your customer? Are you trying to help the ED detect brain hemorrhages faster? Are you trying to help the radiologist find a lung nodule? You know, so, you know, each of those would require almost a different kind of a setup and infrastructure and a different group of stakeholders. That it's quite difficult from that perspective, and that's sort of ignoring the concept that if you were to, you know, for example, you know, sign a deal with a vendor who had an AI model, making sure that it actually did work on your particular data, either as it stood, so the data that you currently have with the machines and the equipment that you currently have, but let's say you buy a new scanner, or you upgrade your GE to, you know, 3.2 to now it's 3.6 software version, and there's a little bit different you know, reconstruction algorithm. Now it looks a little different. Now your model is going to behave differently. So there are things like that are extremely important, that are often not considered at the outset, which is fine. I mean, part of the exploration, you know, from our side is just saying, let's just try it and see what happens. But I think when it comes to actually implementing, as you know, for actual patient care, and particularly if you're going to purchase a product or go down that road, you know, that it becomes a critical component that is not easily answerable.
Yeah, I think also with regard to sort of trying prototyping things and so forth internally, you know, it's important to be good friends with the sort of clinical informatics side of your department as well, because chances are they're getting approached by many different people who have many different ideas or many projects that they might want to get their help in terms of either starting or implementing and so forth. And you know, imagine being in the position of, I have 50 different people with 50 different ideas about detecting this or that on an X-ray or on a CT scan, and they all want them implemented or tested within the clinical workflow. So, you know, you have to be nice to these people in the sense that the more that you can have them potentially involved from the beginning, so that maybe there are some commonalities between projects, or there's some infrastructure that more than one project can take advantage of, I think increases the chances of success in terms of actually testing something or deploying it.
Awesome, thank you. So we're kind of at time now, so thanks so much to everyone for participating. Dr. Taylor, Dr. Lundgren, Chris, that was a fantastic session. And yeah, thanks everyone for your time.
Thank you so much. Appreciate it.
Yeah, thank you.
Yep, thanks very much.